Okay, so we're taking a case of a different type of staircase now. Okay, the problem statement is displayed on the screen. The figure shows a plan of stair hall of a public building which measures 4.25 by 5.25. Vertical distance between the floors is 3.9. Design a suitable staircase for the building. Okay, now it's very clearly mentioned that the type of building is public building. Okay, the stair hall dimensions are given to you as 4.25 by 5.25 and the height is given to you as 3.9. So first and foremost, let us find the number of risers required. To find the number of risers, first thing we need to know is assume the riser. So if I keep a riser of 15 cm, which is always advisable, then the number of risers required will be 3.9 divided by 0.15, that is 26 numbers of risers will be required. Now 26 number of risers, if I provide a dogleg staircase, then there will be 13 steps in each of the flights. Right? Dogleg staircase has only 2 flights. So there will be 13 steps in each. Now again, I have told you in the last class that for public building it is advisable not to go beyond 10 numbers of risers in one single flight. So if you have provided 10 risers, then it's advisable to provide a landing. So what I will do here is we will plan a open well staircase which will have 3 flights. So now it's up to you how you divide these 26 steps into 3 flights. You can divide it as 9, 9 and 8. You can provide it that way. But what I thought is, if you look at it, it is not a square. This is a rectangle. So along this side you can provide more steps, along this side you can provide little lesser number of steps. So what we will do is, I have thought of having 10 risers in the first and third flight and 6 risers in the middle flight. Okay. So let the first and the third flight have 10 risers each, while the second flight have 6 risers. Let the tread be 20 centimeters. Now, if I provide 20 centimeters of tread, how much will be, let's say my first flight goes like this, second flight goes like this, third flight goes like this, okay? So, my first flight, which will travel in this direction, how much will be the length required to accommodate these 10 risers? 10 risers means how many tread? R minus 1. So, 10 minus 1, 9 treads are required in the first and the third flight. So, for 9 treads of 20 centimeter, the total length required will be 180 centimeter. That is 1.8 meters. Okay. So now I'm panning. The problem will not be visible on the screen. So please make sure that you have copied down all this entire thing. Okay, scrolling down. So now the middle flight has R minus 1, that is 6 minus 1, 5 threads. So the length required for first middle flight will be 5 into 20. So far we have not discussed the width of the flight at all. Now for dogleg staircase, what we did was, this is our last problem. How we got the width of each flight? Total width of the stair hall was 2.5. We deducted 0.2 for the wall, so we got 2.5 minus 0.4. 0.2 plus 0.2 is 0.4. We got 2.1 is the effective in dimensions. Divided by that, minus the railing of 10 centimeter we did, and whatever 2.1 minus 0.1 for railing, then 2 meters divided by 2, we got the width of each flight. But here we cannot do that because there are 3 flights. So here the procedure of finding the flight width will be slightly different. So we go back now to our problem. So now, length required for middle flight is 1 meter. Now what we are trying to do is we are trying to find out width of each flight. Okay. What is the total out to out dimensions of this hall is 4.25. Now deduct the thickness of the wall, you get 4.25 minus 0.4, that is 3.85. Okay. Now 3.85 minus the width of the middle flight required to accommodate 5 treads is 1 meter. So 3.85 minus 1 meter of the middle flight, you get 2.85. Now 2.85 is remaining to accommodate first flight and the third flight. So divided by 2, you got the width of each flight as 1.425. Okay, so 1.425 can be the width of each flight. This is the maximum width. You can go for less than that also. Okay, you can go for less than that. But maximum width of each flight can be 1.425. Since it's the public building, we will go for this maximum width. Okay, so I have just drawn this rough sketch for you. Now, the middle flight, this is my second flight, will have only 5 treads. So 1, 2, 3, 4, 5. The first and the third flight will have 10 risers. That means 9 threads. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 threads in this. Total we should get 26 risers. So shall we count? First, second, third, fourth, fifth, sixth, 7, 8, 9, 10. 10 risers of the first one. Then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Right? So you can, when you draw a plan, you draw it like this. Okay, you can write here the landing. What will be the width of the landing? 1.425. You can write it here. Okay, you can also write what is the amount of passage width remains. Okay, so you can write somewhere like this. You can mark it like this. See, my drawing will look very shabby here because I'm not very good at this drawing board handling, but you'll have to do it with a scale. So what will be this size? 5.25 minus 1.8 minus 1.425. So that will be somewhere around 2.025 is the passage width. So this is how you plan. Now, what are the alternative things that you can do? You can change this from 1.425 to any other width. Let's say you decide to take it 1.2. Now, how will this thing look? First thing that will change is, now this 1.8 will remain same. Just instead of 1.45, you are making it a little smaller. Now, let's say you make it 1.2. Only thing in that case, over here things will change. Okay. So, if it is 1.2 and this is 1 meter only, then you will get a quarter ton. And first, you all please copy this. Once you all have copied this, I will show you how the things will change if your width of the flight changes. Okay, if you all have finished drawing, I will just tell you how it will change. Now, if your width becomes less than 1.425, in the plan, in your drawing, how it will change? This will go little lesser. Okay, similarly, this will go little lesser. But now, this riser will still be in the same place, centrally located. So you will have one riser drawn here. One will be somewhere here. And one will be here. Okay, so what can you see now? Over here what has happened? The flight ends here, but the riser immediately doesn't start in line with the railing. First riser will come slightly ahead. Are you understanding? Previously it was how the flight exactly ended. I'll show you how it was previously. Previously how it was, your riser ends here, okay, and then you take a quarter turn and the next riser starts. But if the flight width is less, okay, then this line goes before, this line goes here this way. So your riser now will not start immediately in line with the railing in the plan. Your riser will not be here. Your riser will not be like this. Understood? Your riser will start a bit late. Similarly, in this case also, the last riser will be little earlier. Before you take the turn only, your riser will be there. That kind of a thing is not really, safe. People anticipate after the turn that you will get a step next as soon as you take a turn. So, ideal will be whatever is the maximum possible width you keep it. Of course, if you are planning to have a lift in between in the open well, then this 1 meter may not be sufficient. The gap that you get in between may not be sufficient. But all that you are not required to plan. In reality, 1 meter may not be sufficient to provide a lift. But still, for you at this stage, this much is okay. Now, how will this section look? When you take a section, first thing you need to do is you draw the section line. Section has to pass through at least one flight, at least it has to pass through. So let's say your section line is this, okay, and your movement is you take the section line through this, okay. This is your section line, and let's say your movement, your arrow movement, this arrow is also important. You have to mark this arrow. You have to show it like this, and like this. That means this is your first flight, this is your second flight, and this is your third flight. Also show the numbering of the steps, okay. So this is your first step, second step, like this you have to show. Not each one, but you have to show otherwise. So third, fourth, fifth, sixth, seventh, eighth, ninth, and this becomes your 10th, like that you have to show. Okay. And similarly, this is your 26th and 25th. Yeah, whatever. So you have to show this. Okay. So now concentrate on this red section line. How will your section look? When you are standing this side, you are standing here and looking at the cut section through the first flight. How will it look? Now to draw the section, you need to calculate the height of each flight. The first flight starts like this. Okay, the first flight starts like this. There are 10 rises, right, in the first flight. So 10 into 15 will be the height of first riser. Okay, that is. Similarly, what will be the height of the second flight? Second flight will be 10 plus 6 risers in the second step. So 10 plus 6 into 15, that is 2.4. Okay, so 2.4 meters. This is 1.5 meters. So here draw these horizontal lines, which I have purposely drawn in very light color, and line weight, the thickness of the line is also very less. These are construction lines, they don't need to be drawn. After that, you need to get 4 points. First is first step riser, then this point where the last riser of the first flight ended. Then first riser of the third flight, last riser of the third flight. Now what are these points going to give you? These are going to give you the line, or this is called the riser line, or ringing line it is called, along which your flight is going to be seen. So now I have connected these points, red points, with a very light construction line, these red points with another light construction line. Then the middle flight, I have marked the 6 risers. This will be the first one, second, third, fourth, fifth. There should be 6th one. So maybe another one. Okay, fine. So there will be 6 risers. Just excuse this drawing. This is anyway not to scale. After that, what you are going to do? Now this is your first riser. No? Now you start drawing the steps. Okay, 20 centimeter horizontal line, 15 centimeter vertical line. So you should ideally get, now I have drawn it haphazardly, it may not be 10 steps, it may be a little more or a little less also, I don't care. But you all have to get the exact steps. Or once you have drawn it from the plan, you can project these lines down. Okay, in light colors you can project this down and then draw this. Or you can directly take your scale, measure 20 horizontal, okay, and then you draw this. After that, the last thing you need to do is, now this is going to be a landing, no? So Over here I told you around 17 centimeter base slab you have to take 17 from here, perpendicular direction. This has to be 17. So approximately 2 mm you take. Okay, go straight like this. And so once you have drawn this base slab, this line, okay, below the steps, then what you do from now, this is your landing, right? You guys can't see the cursor, so I'll use red color. Okay. So now this is your landing. Below the landing, you go down by 17 centimeter and draw another line. And wherever this line and this base slab line intersect, just join it like this. Okay. Similarly now here, okay, what you will do, you will take a point like this, 1.7, so around 2 mm down. And then what you will do, you will draw a line. This line and this line have to be parallel. Okay, so you draw this line. Then again similarly, below this line you go by around 17 centimeters, so around 2 mm, and then just join this. Okay, after that what you will do, you will mark here step 1, step 2. Okay, so there are how many? 10 risers, no? So over here you will mark 10. Okay, 11. You need to mark each and every one. Now once you, then over here what it is around 10 plus 6, no? So this will be your 16th step. This is your 17 and this will be your 26. Okay, this is how you will draw. Then you have to hatch this. Okay, you have to hatch this dots and triangles, that stands for RCC. Sorry, you are not going to hatch this flight, only this flight. The section has not passed through this. So, okay, hatching is not going to be for the third flight. The section is passing only through the first flight, no? So hatching will be only for the first flight. Okay, so you will hatch this. Okay, you will hatch this. And this will be your section. Okay, typically know how this section of this open well looks. You will see it in the video on staircases. So see, this is a beautifully drawn section. This is how the architects will draw. Okay, they have numbered the steps here. Can you see? This is where the steps are numbered. Okay. Then they have given a scale also. You are not required to do all this. You can just add few numbers here, then few numbers here, few numbers here. Then they have given all the detailings, rating and all. You are not expected because we usually provide RCC details. We don't provide like this planning details. As engineers, that is not required. Okay, so that is how we will finish this. Now you have to answer one question. If this staircase width was less than 4.25, would your section change? Will there be any change in the section? Think, I had shown you how the plan will change if the staircase width is in place of 1.425, let's say make it 1.2. Will my section change? It will not change because this dimension is not seen only anywhere in the section. You only see the height and the length. In the plan, what you don't see? You don't see the height. You only see width and the length. So when your width changes, you will not see it in your section. However, in the plan, there will be a lot of changes. Okay. So if you still have doubts, you can get back to me and maybe you